Hi, welcome to Automotive Appreciation Part 8. In this course we learn about braking systems, disc brakes, drum brakes, vacuum assist system, diagonally split brakes, anti-lock brakes and ventilated discs. When we get a car to move, the next issue is how to stop it safely. This is achieved with the brakes, which convert kinetic energy into heat using a hydraulic braking system. We start with disc brakes. The disc or rotor is attached to the wheel and is surrounded by the brake caliper. The brake pads are located on both sides of the disc. With a hydraulic system, when we apply a force to an incompressible liquid, the force is transmitted throughout the fluid. By adjusting the size of the pistons, we vary the available force and the distance travelled by the slave cylinder. Here we see the master cylinder with a reservoir for brake fluid on top. When the pedal is pressed, the piston moves forward and closes off the inlet from the tank. The fluid is then pressurized and activates the slave cylinders. When the brakes are applied, the rubber seal deflects slightly. When the brake is released, the seal returns to its normal shape and moves the piston back slightly from the wheel. If the fluid expands due to heat, some can return to the reservoir. If there's a leak in the system, the fluid will be topped up from the reservoir. Excessive leakage will be detected by the level switch. If there was a severe leak in the system, we would lose all brakes. This is a single piston floating caliper, self-adjusting and self-centering, which is used in most cars. Cooling air is channeled over the brakes to assist with heat dissipation. Periodically, the pads will require changing. Some pads have a metal wear indicator which makes a squealing noise when it contacts the disc. Other cars have wires embedded in the pad. When the pad wears out, the rotor completes the electrical circuit and activates a warning light. In the past, the friction material was secured to the shoe with rivets, but now a bonding adhesive is used. Drum brakes consist of an outer drum which the wheel is attached to and the inner brake shoes. When the pedal is pressed, the high-pressure fluid forces out the two pistons in the brake cylinder, pressing the shoes against the drum. When this brake shoe contacts the drum, there is a wedging action, which helps to increase braking force, but it also requires a spring to retract it. When the brake pads wear, the adjuster is used to alter the bottom anchor position. The handbrake or emergency brake is independent of the hydraulic system and usually cable operated. Drum brakes are more difficult to inspect, service and cool. Under heavy braking, the brakes will heat and become less effective. This is called brake fade. As disc brakes do not have a wedging action similar to drum brakes, considerable effort is required to operate them. Usually a car will have a braking power assist system. This uses vacuum from the air intake system. When the car is started, there's vacuum on both sides of the diaphragm. When the pedal is pressed, it first closes the valve to the vacuum side and then opens the valve to atmosphere. Now there's a pressure differential across the diagram. Vacuum on one side, atmospheric pressure on the other, which assists with application of the brakes. When the brake is released, the valve to atmosphere is closed and the vacuum valve is opened, restoring a vacuum on both sides. With the dual circuit braking system, there are two pistons in the master cylinder. When the brake pedal is pressed, the piston moves forward, pressurizing the fluid, and also moves the second piston forward. A similar high pressure will be exerted in both lines. Again, assistance will be provided by the vacuum assist. If we have a leak in the left-hand circuit, its piston will move all the way to the left, as there is no restriction. The brake pedal will depress further, but will eventually build pressure in the other circuit. The division in the plastic storage tank ensures that if we have a leak in one circuit, we'll not lose all the fluid in the other circuit. If we have a leak in the right circuit, this piston will strike the other piston and build pressure in the healthy circuit. As the brakes will only be applied to two wheels, braking force will be compromised. With diagonally split brakes, two circuits are used. Circuit 1, front right and back left. Circuit 2, front left and back right. If a leak occurs on one circuit, the car can still be stopped with the other circuit. A car has the optimum grip when the tyre is on the verge of sliding on the road surface. When the tyre is sliding, the grip is reduced dramatically. To prevent the wheel from sliding, an anti-lock braking system is used. Here we have a 4-channel, 4-sensor ABS system where each wheel is controlled individually. Wheel speed is detected by a proximity sensor located beside a toothed wheel which sends a signal to the ECU. Between the master cylinder and wheel is a modulating valve. Imminent wheel lock can be determined by one wheel decelerating at a higher rate than the other 3 wheels, or a wheel decelerating at a rate which is physically not possible without locking up. When the ECU determines that a wheel is on the verge of locking, the ECU activates the modulating valve and releases the brake pressure. The modulator valve is normally in the open position and has no effect on the braking system. At the top left there's a connection to a high pressure pump, and at the top right there's a connection back to the reservoir. Bottom right is the input from the master cylinder, and bottom left is the outlet to the wheel. When the ECU detects that a wheel is on the verge of locking, it activates the ABS solenoid. The solenoid moves to the left and allows through the high-pressure fluid from the pump. The high-pressure fluid exerts a force on the piston and closes the valve against the spring pressure. When the piston moves to the left, it also allows more place for the brake fluid and reduces its pressure, releasing the brakes. When the solenoid is de-energized, the high-pressure fluid is released back to the reservoir. The spring force opens the valve, and the additional rod volume also increases the fluid pressure and reapplies the brakes. This cycle can happen 20 times per second and results in a pulsing sensation in the brake pedal. ABS pulses the brakes on and off. It prevents the wheels from locking, the car will stop in a shorter distance, and it can be steered. To improve braking performance and avoid brake fade, ventilated brake discs are used. They consist of 2 discs separated by vanes or fins, which allow air to circulate for cooling. Slots and holes also help to improve air circulation. Under heavy braking, the weight of the car is transferred towards the front. Therefore, the front wheels do most of the braking. Also, when a car corners, the weight will be transferred to the outside wheels. When the weight is transferred to one side of the car, there is a possibility of the wheels on the other side locking. EBD, electronic brake force distribution, uses many of the ABS sensors to determine wheel speed, and also the steering wheel position sensor to determine the intended path of the driver. This data is processed by the ECU to determine if some of the wheels are lightly loaded. The braking force is reduced on the lightly loaded wheels and increased on wheels which are braking most effectively. In effect, the EBD activates before an ABS situation arises and helps to improve stability and reduce stopping distance. Similar to other systems controlled by the ECU, if a defect is detected in the ABS system, the driver would be alerted via a warning light. We hope you learned from Automotive Appreciation.